The Atlas Anomaly, the day the universe answered. The Midnight Visitor. The date is December 19th, 2025, in the quiet, high-altitude observatories of Mauna Kea and the Atacama Desert. The cooling fans of supercomputers are the only sound. But inside the digital veins of these machines, an alarm is screaming. Right now, as you sit in the comfort of your home, a visitor from the deepest reaches of interstellar space is skimming the gravitational surface of our solar system. We are tracking an object officially designated as 3IATLAS. It has just reached its absolute closest approach to Earth, passing us at a distance of 1.8 astronomical units, roughly 270 million kilometers away. In the vast scale of the cosmos, that is a hair's breadth. This is not just another wandering rock. This is only the third time in human history that we have confirmed a visitor from another star system. We remember Oumuamua in 2017, the cigar-shaped mystery that defied explanation. We remember Borisov in 2019, the rogue comet from a distant sun. But 3IATLAS is different. It isn't just passing through, it is changing. And it is changing in ways that our current models of the universe say are impossible. Tonight, we are performing a deep dive into the real-time data streaming from the James Webb, Hubble, and the world's most powerful ground-based arrays. We are looking at the spectral shifts, the trajectory anomalies, and the rhythmic pulses that have kept the world's leading astronomers glued to their monitors for 72 hours straight. What we are seeing tonight suggests that 3IATLAS is either the strangest natural phenomenon we have ever witnessed, or it is something else entirely. The color of the impossible. Let's look at the data coming from the Gemini Observatory. Only 48 hours ago, 3IATLAS was nothing more than a faint magnitude 18 smudge on a CCD sensor. It looked like a standard interstellar comet. Astronomers expected a predictable show. As it neared the sun, the ice would melt, it would brighten, and then it would fade back into the dark. That is not what happened. Instead of a steady glow, the object's luminosity spiked. It didn't just brighten, it flared. But the real mystery wasn't the intensity, it was the color. As it crossed the frost line, the object displayed a distinct, vibrant blue hue. In standard physics, we see this when carbon monoxide or ionized nitrogen sublimates into space. We've seen blue comets before. But then, as it hit the 1.8 AU mark, Earth's neighborhood, the spectrum shifted. The blue gave way to a piercing neon green. Green comets are rare but understood. Diatomic carbon and cyanogen gas can glow green when bombarded by solar ultraviolet radiation. If the story ended there, we would call this a chemically rich but natural body. The story does not end there. In the last 6 hours, the green has been overtaken by a metallic, golden tint. This is where the scientific community began to panic. There are almost no natural processes in a cometary tail that produce a sustained, mirror-like golden reflection. Sodium can appear yellow-orange, but the spectral signature doesn't match. This doesn't look like gas. It looks solid. It looks like a reflection off a hull. The object's albedo, its reflectivity, has skyrocketed to 80%. To put that in perspective, that is the reflectivity of fresh, pure snow or the icy moon Enceladus. But Atlas isn't ice. It is currently basking in the full, brutal intensity of the sun. Any ice should be exploding into a chaotic cloud of gas. Yet the coma around Atlas is tight, controlled, and almost aerodynamic. The heartbeat in the static. While optical telescopes were watching the color show, the heavy hitters, the Hubble Space Telescope and the Chandra X-ray Observatory, were looking at the object in the high-frequency spectrum.
Comets do emit X-rays. Usually, this happens when the solar wind slams into the cloud of gas surrounding the nucleus. It's a messy, diffuse process. We expected a soft, random glow, but what we got instead were sharp, rhythmic peaks. The X-ray emissions are pulsing. They aren't random fluctuations caused by the turbulence of the solar wind. They have a structure. A NASA report updated just minutes ago noted that while this could be an interaction with solar wind, the amplitude is far too high. The gas cloud is too thin to produce X-rays this blindingly intense. What does this mean? It implies that the thing the solar wind is hitting isn't a cloud of gas. It is a solid, highly conductive surface. If you have a metallic body rotating in a magnetic field, you generate exactly the kind of X-ray peaks we are seeing. This is where the science gets uncomfortable. We are looking at an object that changed from blue to green to shimmering gold, all while pulsing with high-energy radiation like a beacon. Is this a volatile mix of exotic ices we've never encountered, or are we looking at something manufactured?
The pilot's touch. A rock falls where gravity tells it to fall. This is the law of the universe. We can predict the path of a comet to within meters using the clockwork of orbital mechanics. But 3IATLAS is disobeying the law. Data from the James Webb Space Telescope has confirmed a non-gravitational acceleration. Now, Oumuamua had this too, the rocket effect of venting gas. But ATLAS is different. Its deviation hasn't been a slow drift. It shifted its course by approximately 60,000 kilometers in a single window. In space, 60,000 kilometers is a canyon. If you throw a ball and it suddenly turns mid-air, you know a force acted on it. But the outgassing theory doesn't fit here. The deviation wasn't just away from the sun. It had a lateral component. It moved sideways. Nature doesn't move sideways. Nature moves away from heat. A lateral shift implies a controlled vector, a maneuver. Why maneuver now? Because 60,000 kilometers is exactly what was needed to line up the next leg of its journey. It wasn't an error, it was a correction. The wow connection. This is the part of the story that keeps astronomers awake at night. Harvard astrophysicist Avi Loeb has pointed out a chilling coincidence. When we trace the trajectory of 3IATLAS backward, rewinding the clock through the decades it spent in the void, we find that its vector of arrival aligns precisely with the region of the sky where the famous WOW signal originated in 1977. For the uninitiated, the WOW signal was a 72-second blast of narrowband radio noise that remains our strongest candidate for an extraterrestrial transmission. It never repeated. It was a ping in the dark. What if that signal was a handshake? And what if 3IATLAS is the response? The probability of a random rock falling into our system along that exact line of sight is 1 in a billion. If it is a rock, it is a statistical miracle. If it's a probe, it's a flight plan. The Jupiter uplink. 3IATLAS is currently speeding away from Earth, but it isn't heading for the exit just yet. It is threading the needle of our solar system to line up a rendezvous with Jupiter in March 2026. Jupiter is the king of planets, a massive gravity well, and a source of immense radiation. We use Jupiter as a slingshot for our own probes, Voyager, Cassini, New Horizons. But those missions require months of complex math to hit the perfect gravity keyhole. 3IATLAS is aiming for that exact keyhole. But it isn't just seeking a speed boost. Jupiter is surrounded by icy moons, Europa, Ganymede, Callisto, worlds with subsurface oceans, prime candidates for alien life.
The course correction Atlas made near Earth has put it on a path that will take it directly through the orbital plane of these moons. If you were a scout from another star and you wanted to scan a solar system, you would visit the two most important places, Earth for its surface biology and the Jovian moons for their subsurface potential. Atlas is doing exactly that. And as it enters Jupiter's massive magnetosphere, we expect it to light up. The interaction between the object's conductive hull and Jupiter's magnetosphere will likely create radio bursts and auroras visible from Earth. We might finally see the machine turn on. The silent departure. After Jupiter, the math says Atlas will leave us. It is traveling at a hyperbolic velocity. It is moving too fast to be captured by our Sun. By the 2030s, it will cross Neptune. By the 2040s, it will be back in the interstellar void. If it is a rock, this is goodbye. But if it is a probe, the mission is only beginning. Avi Loeb speculates that as it leaves, it will use the energy gained from Jupiter to fire its high-gain antenna. It will blast the data it collected, our atmospheric composition, our radio leakage, our city lights, back to its home star. We are watching a visitor take our fingerprint back to the shadows. The cognitive dissonance. The mainstream scientific community is hesitant. They are conservative. They don't want to say the A word, artificial. They are desperately trying to invent new natural theories to explain the gold color, the X-ray pulses, and the sideways maneuvers. But as the list of 1 in a billion coincidences grows, the natural explanations become more convoluted than the artificial ones. Occam's razor, the principle that the simplest explanation is usually the right one, is starting to point the other way. Is it simpler to believe in 5 brand new, never-before-seen natural phenomena occurring simultaneously in one object? Or is it simpler to admit we are looking at technology? The Atlas anomaly has forced us to look at the sky differently. We no longer live in a quiet, empty neighborhood. We live in a busy intersection. What do they see? As we watch 3IATLAS fade from the view of our binoculars, heading into the cold dark of the outer planets, we are left with the most haunting question of all. If this is a probe and it is scanning us, what does it see? Does it see a planet brimming with potential, or does it see a biological sample in a petri dish? Does it see a threat, a curiosity, or just a milestone on a much longer journey? We may not get an answer tonight. We may not get an answer in 2026, but the legacy of 3IATLAS is already permanent. It has shattered our isolation. It has reminded us that the universe is wide, and we are very, very small. Somewhere out there, in the direction of the constellation Hydra, a golden mirror is reflecting the light of our sun. It is a silent watcher, a messenger from a star we may never visit. And as it glides towards Jupiter, it leaves us with the only truth that matters. We are not alone. We have never been alone. And the stars are finally looking back.